With Nagarro's diverse range of resilience engineering services, you can build robust and reliable systems and ensure business continuity. Our tailored solutions ensure that your brand has the unbeatable advantage of staying at the top, even during unforeseen events.
Hey everyone, how's it going? I hope day two serves you all well and you get a lot of insights from the second day of Chaos Carnival. Today here with me is Kavin Arvind Ragavan. He's a cloud performance architect with over a decade of experience in performance and reliability engineering. He specializes in AWS and GCP cloud performance and resilience engineering. In this demo, Kavin will showcase how chaos engineering can be automated and made a build step in the CI/CD pipeline, which allows chaos experiments to be applied on cloud services during deployment, which is also early in the life cycle. So yeah, don't miss this opportunity to see chaos in action from Kavin himself in the CI/CD tool. Bring it on.
Thanks for the introduction. Hi all. Good afternoon, good evening, and good morning to everyone who joined this session from all over the world. Uh, Thanks for joining this session on Meet Chaos in CICD. This is Kavin. I'm a cloud performance architect with Cognizant, and I work on performance engineering, site reliability engineering in chaos and observability space. So, welcome to the workshop. I know we are getting a lot of insights on chaos engineering over the past 24 hours. Speakers from all over the world are giving their insights on chaos engineering, and as a couple of speakers have rightly said, the importance of shift left chaos testing in the pipeline. So, I believe this session would give a deeper insight on that and would give us a realistic picture how we can introduce chaos in any CI/CD pipeline. So over to the session. So this is the high-level agenda that we are planning at today. So we'll discuss about the necessity of continuous resilience and what are the key objectives that we are trying to accomplish as a part of CI/CD resilience validation. What are the different hotspots across which we can introduce chaos, and what kind of chaos we can introduce across these hotspots. And I'll also show you a fault injection library that is built with the different kinds of faults that is possible across the infrastructure as a service, container as a service, and platform as a service offerings in any cloud infra. And while walking over this, I'll explain how we can configure the credentials and chaos documents for our CI/CD approach that we are going to explain with the help of AWS Cloud Formation and Jenkins. And we'll also look into how we are going to automatically validate the SLOs for these chaos experiments in CI/CD. What is the observability setup we have made to monitor the application and infra metrics under a chaos experiment, and also a resiliency scorecard, which helps us to understand how our application scores with respect to resiliency. So, coming to the necessity part. So, why we need chaos in CI/CD? What are the benefits we accomplish as a part of introducing it in that pipeline during every build or deployment? So when we try to safely introduce a chaos in the CI/CD pipeline along with the performance testing stage, it helps us to access the application with respect to these five factors. So we can try to detect any issues in the application under a production load. We can try to mimic these real world scenarios safely in a non-prod environment and validate the application for availability, in which we can make sure the application is up and running during the fault simulations. So if you're going to introduce a zone outage, or if you are going to introduce a RDS failover, or rebooting a cache server during a load test, then we can ensure how much time the application takes to be back uh, up and running, or how much downtime we are facing. And also it helps to understand the recoverability, in which we can capture the mean time to recover, which helps us to understand how soon the application recovers from these failures gracefully. And also it helps us to validate the reliability part, in which we can validate how much errors or how much 5x's errors or 4x errors we are seeing during a chaos experiment, which helps to assert our application is reliable 99 percentage or up to 3 nines or 4 nines of reliability under chaos. So the other critical part that we are going to validate here is integrity. We can also validate the data integrity, in which under chaos experiment there is no data loss is happening. The final thing, which is also a key factor, it helps us to validate our applications. Each and every state is highly observable during the failures. So this helps us to validate our applications properly instrumented with enough metrics, logs, and traces we require to debug any chaos incident. So coming to the key resilience validation objectives. So this spectrum would give you a clear understanding of the different uh, possible hotspots that an AWS infrastructure can have. So I have focused this presentation based on AWS infra, because the fault injections we are going to simulate today is for AWS infrastructure. So let me talk in context with respect to AWS. So, as you can see, the different spectrums of chaos can cover, or it can target the compute, the containers, database, storage, and network areas. So, after analyzing the application architecture and also its infrastructure, we can try to categorize or pick up our chaos experiments by identifying the weak spots in the architecture across these areas. Even if the application is having a serverless infrastructure or a container based infrastructure or a compute infrastructure, if it is having EC2 or EKS or RDS. So, based on the different uh, architectural elements we have in our application, we can try to pick our chaos experiments that I'm going to explain you in the next slide in the fault injection library. And we can try to evaluate our application with respect to these experiments. So you would be surprised at the level of issues we can validate under a resilience test. So as you can see here, we can validate the application's latency issues. We can try to understand the application's error rate under a chaos. We can try to find the impact to application functionality under these faults. We can see how much time the instances are taking to turn around. It can help us to validate the scaling triggers, validate auto scaling, and also it can help us to validate lot of settings with respect to load balancing, health checks. And when you come to Fargate, it can help us to find any issues with the task scheduling or load balancing, the container health. So, like this, the issues or the configuration things or infrastructure failures that a chaos test can uncover, it's very huge. So we may not understand it until we try a chaos experiment across these services. So when these chaos experiments are tied up with the observability, and when we try to capture metrics across the below categories I have mentioned here, it helps us to pinpoint any issue that the application can face and how it can respond to that. So coming to the fault injection library that I was talking about, so um, the different faults that we can inject across the infrastructure can be categorized into multiple types. I have categorized into five kinds here. So the component level, resource level, network level, application level, and database level. So, as a couple of our speakers were pointing yesterday, the component level faults, it involves terminating or rebooting a random instance across a zone, or causing any zone level failures, or like stopping a pod, or terminating a pod or node, or even if it is serverless, we can try to stop a ECS task or reboot a RDS. So like this, if the chaos injection is going to um, impact the state of any particular component we are having in architecture, it's called as a component level fault. In the same way, we can try to introduce resource level failures, network level failures, say high CPU usage or memory usage across the instances, introducing a network latency or packet loss across the zone. So like this, multiple chaos can be introduced, and all these uh, chaos injections are possible through CICD. Whether we use a litmus for introducing chaos into Kubernetes, or if we use AWS FIS or AWS SSM for introducing chaos into AWS infrastructure. So whatever tool we use, it can be the experiment can be triggered using a CLI command, through a kubectl command or AWS CLI command, which we can leverage to introduce as a part of our CICD pipeline. So, for the context of this presentation, I'm going to show a pipeline in which we are going to introduce chaos into AWS using AWS Systems Manager and Jenkins. So, this article, which is written by one of our keynote speaker, Adrian, who gave us the keynote speak yesterday. So this explains very clearly how we can introduce chaos into AWS using AWS Systems Manager. So Adrian has provided set of SSM documents which helps us to introduce a variety of failures into the AWS infrastructure. So as you all know, AWS Systems Manager is the kind of service that AWS provides to do operational aspects on AWS resources. So it allows to create documents either through automation documents or run commands option, which serves as a chaos experiment files, which can be injected across the AWS resources. So feel free to scan this article and have a look at how it works. Um, I'll explain how we are going to introduce that as a part of our Jenkins pipeline. So coming to this approach, so I have my Jenkins server running on a particular AWS account and my application hosted in another AWS account. Okay, so in order to safely execute these experiments from my Jenkins account, I am going to use assume role. So I am going to configure my account as a trusted entity to the consumer AWS accounts IAM, and I'm going to assume temporary credentials while I'm going to execute these chaos experiments. So coming to my CI/CD pipeline, I'm going to customize all the different fault parameters as Jenkins parameters. Say if my AWS CLI command to introduce this chaos is going to introduce this chaos across a particular region or across particular zone. I'll show you sample AWS CLI command now. So I'm going to configure all the different fault parameters as Jenkins parameters. So which zone I want to introduce that, which region, or what kind of fault, how much duration I want to introduce the fault, what is the intensity of the fault, say in case of network latency, how much uh, um, delay I want to introduce into the infra. So like that, all these inputs that we want to pass are configured as our Jenkins parameters. And this chaos testing job will be running in conjunction with the load test job, in which any tool like JMeter or K6 would be introducing load into the APIs, and at the same time our chaos testing job would be triggering the AWS CLI command, or it can also trigger a chaos mesh command which introduces these failures into the infrastructure, and we are going to monitor those failures in the Grafana setup that we have created by pushing the metrics from JMeter, or also the metrics from any APM tools we have, which serves as a single place to monitor all the chaos metrics. So, as I mentioned, the different fault levels like state, resource, and network level faults across infrastructure, application, database can be introduced right from our pipeline, and automatic SLA validation can be did with the help of our load testing tool, which helps to fail this job when the thresholds are reached. We'll discuss those things later in this presentation. And coming to how we are automating this. So the first step is the creating of a chaos pipeline, in which we are introducing a chaos testing stage as a part of our load testing stage, and also we are going to create a chaos observability dashboard in which we are pushing metrics from our load testing tool like JMeter, and also metrics from a cloud using a CloudWatch plugin or any APM data source. So these two are the prerequisites we are setting up, and then we are having two services here. So one is the resilience deployment service and the resilience testing service. So the different chaos documents that are required to introduce the different faults into the infrastructure. So those can be clubbed into cloud formation along with the necessary roles and permissions required to inject those failures into the instances. For example, if we need to introduce these chaos into the EC2 instances, we need the EC2 instances should be assigned with the IAM role that have SSM full access. So all these kinds of configurations, IAM roles, permissions, and the different chaos experiment files in SSM format, all these will be combined into a cloud formation template. And once that is deployed in our application AWS account, we'll be having all these documents with the enough privileges attached to it up and running. And coming to our resilience testing service that we are putting in Jenkins here, which can also be planned through any of the CICD tool, we are going to create a load testing job and also a chaos testing job, and we are going to configure our CLI commands with the different fault parameters I explained before. So for getting the temporary AWS credentials in a secured format and not to expose the AWS credentials in executing the CLI commands, we can use AWS STS get caller identity function, which retrieves the temporary credentials from the AWS account. So for this, I'm going to configure my AWS account in which the Jenkins is hosted as a trusted account to the application's AWS account. And this shows the cloud formation template in which I have clubbed the different SSM documents which can do the multiple fault injections. So these documents can be automation documents, which can do variety of actions like rebooting a RDS or failing over RDS, rebooting a random instance in a particular zone, or terminating instances in a particular zone. So based on the different functionalities, we have different documents, and these documents are highly customizable. In case if you want to introduce CP stress in a fashion, say in incremental fashion, you can customize these documents accordingly. And if you can see here, I'm going to execute these documents as a part of my build step, in which I'm going to invoke these documents through my AWS SSM send command. Here, I'm going to trigger the document, and I'm going to pass the different parameters in it. I'm going to create a resource group in AWS which clubs my application instances. For example, all the payment services can be clubbed inside a resource group called payments group. All the claim service can be clubbed into a claims group. Like this, the different functionalities belonging to each of those instances, we can categorize those into resource groups, and we can target our chaos into a particular resource group to identify any single point of failures. What happens if the payment service is down? What happens if the claim service is down? So we are targeting it based on the resource groups, and we are passing the inputs, how much uh, fault intensity I'm going to target, how many instances, or how much load, how much of CPU stress, and how much duration I want to pass these of failures. So all these things will be configured and passed through this CLI command. So the same way, there is an option to trigger automation document. So those documents allow us to run AWS functions to accomplish different actions. You can write a AWS automation document to reboot Elastic Cache server, or you can create a automation document to fail over a DB instance. So there are two kinds of automation documents available. One will allow you to execute a command over the instances. The other would allow to do any operation, state level operation on the instances. So this shows a sample pipeline in which we have did the same in a pipeline format. So after the load testing stage, or in the peak phase of a load testing stage, we are going to introduce a chaos testing stage, which introduces controlled chaos experiment in a non-prod environment. So when we try to introduce this in our CICD pipeline, so how to make the build fail, or how to understand in case of any issues happening. So when we try to introduce a load using a tool like K6 or Artillery, so they help us to do automatic SLO validations using thresholds. So we can define thresholds in our load testing or chaos testing stage in the script, in which I can configure thresholds to make the build fail if the response time is taking more than 500 milliseconds, or if a specific endpoint is not meeting its SLA, or if 99% of requests are not below the SLA. So like this, we can try to configure different thresholds, and our mean time to recover our RTO objectives. We can also try to accommodate in our load testing scripts, and the build will be failed accordingly, passed or failed accordingly. So coming to your resiliency scoring, so we had a couple of speakers walking over us on the resiliency scoring mechanisms yesterday. So obviously, a resiliency test makes sense only if it is scored. So these are the different metrics that we can capture during our chaos experimentation, and validate the application based on these. So, based on infrastructure, application, and database, the different metrics has been gathered here. So, for example, how much time for if the instance are taking to recover if a particular zone is terminated, or the CPU memory disk of the other nodes are getting down when I'm going to introduce chaos on a particular node, how much 5xx or 4x errors I'm getting during the test when I'm injecting this chaos, or are there any latency issues in my APIs when I'm introducing this chaos? If means how long, how much time it is taking to recover. So how the application traffic is getting impacted during this chaos. And as I said, we are going to validate the data, also data consistency in database as well. So how is the application functionality is getting impacted during a failover? Are my application instances getting a health check failed during its database failover? Are they coming back sequentially or parallelly? So all these kind of things can be validated, and the scoring is based on the impact it's causing. So we can also define resiliency SLAs, in which we can define uh, how much time it can take for the instances to back up and running, or how much time I'm expecting all the failures to get resolved, or how much time the response times can breach the SLA. So all these things we can define as resiliency NFS, and we can score based on the impact it is causing. Um, so coming to the observability part, how we are going to observe these um, impacts easily at a single place. Um, so from the load testing tool, whether it can be load runner or JMeter or K6, we can push the metrics to Grafana through Influx data source, where we can monitor the API level or transaction level response time details, error rates, throughputs, everything we can monitor in a Grafana. And at the same time, when we try to correlate these application metrics along with the cloud metrics, so based on all the services in my applications architecture, so those things can also be pushed to Grafana through the CloudWatch data source, or if you're having any APM tool, we can push through that APM tool as well. The purpose why we are trying to bring everything into a uh, single source of truth here is we can have a single place where we can correlate both the application and infra metrics, and try to correlate the application failures along with the metrics from the cloud, whether it can be load balancer or auto scaling groups or target groups, or the database metrics. I can try to correlate my application response times and failures with the metrics from the cloud, and I can try to derive my recovery time based on that. For example, upon the introduction of a chaos, if I'm seeing a huge spike in the errors, and after after some 5 to 10 minutes, when everything gets resolved through auto scaling or through any graceful recovery mechanism, we can try to see how much time it took for the error rates to diminish to zero. So which helps us to identify the recovery time. Like this, the different chaos observability metrics can be monitored from the chaos dashboard we have created. So that's it. We have came to the end of the presentation. So we have seen a chaos CICD approach that we have implemented using Jenkins and AWS Systems Manager. So the same approach can be leveraged across any CICD tool or any chaos tool. And by embracing such approaches, we can improve the stability and reliability of our application, and it helps us to give a better user experience as well. Thank you.
Awesome. Amazing. Interesting topics that we have there. So let's address all the questions. I think people, if you have more questions, you can ask them on the chat or on the Q&A. I had a few questions on the Q&A, but I'll just take this one first, which is uh, the differences between chaos engineering and disaster recovery.
On the difference between chaos engineering and disaster recovery test. Okay, so disaster recovery test to focus on causing complete outage. So if we cause the experiments at a limited fashion, like targeting only few EC2 instances or few EC tasks or any database instance in a particular zone, then that's a chaos experiment. When we try to wipe out the entire region, then it's called as a disaster recovery.
Okay, got it. Cool. So, and one thing I was curious about, if you have, like, from your experience, if you have some common challenges that organizations face when they try to automate these chaos experiments in the deployment process. Get those?
Yes. So since we can try to observe the impact of chaos only under a load. If we try to inject these experiments when the functional and non-functional testing is not successful, then obviously we'll face some issues. In such cases, we cannot differentiate the failures that is caused due to this chaos and the failures that are caused due to the other issues. So obviously, so to automate these chaos experiments, we have to run these experiments at least when the QA stage is passed. So obviously, we have to wait till the QA and performance stages are passed so that we can continue this in the deployment process.
Got it. Makes total sense. Okay, and another last question we can take is like these processes when we deploy them, when we integrate them in our deployment process, in our deployment stage, right? Do they slow things down, or like in terms of speed and quality? And do organizations measure this impact?
So if we are worried about the speed, or if in which like it may delay the pipeline process, then in such cases we can um, um, avoid the automatic SLO validation process. So the build will however continue to pass in case of any issues. In other ways we can do is, instead of running a fully blown peak load test, we can run a chaos experiment for 5 minutes and a load test for just 5 to 10 minutes. So we can try to minimize the load test, and we can try to introduce any random chaos experiment for every deployment. So which can help us to improve the speed of the pipeline, and it won't delay it further.
Mm, got it. Makes sense. Makes sense. Thank you so much, Kavin, for answering all the questions and for such an interesting demo and presentation. So yeah, folks, stay tuned. We have more talks coming up, and join the next one. We have two amazing talks lined up next. And yeah, thanks again, Kavin, for joining us.
Yeah,
Have a good
thanks.
day.